Hi everyone. I'm Nandakumar Jia from Cybersecurity Department, and my team members were Tejasvi Kabir F and Dinesh Kumar B from CSC Department. So, project title is Runtime Malware Detection using OS level behavior. So, let's check on the introduction part. So, the traditional antivirus fails against unknown and zero-day malware. So, this project is mainly aims for monitoring the real-time OS level behaviors like processes, files, and those network activities. And it also ensures to detect the malware based on suspicious behavior patterns, but not like the signature ones, because when the CPU goes high or when the memory has been consumed on more than usual, so these kind of patterns has been used to detect these kind of suspicious behaviors. And it also provides the faster and more reliable protection against modern cyber threats. And it also helps to identify the fireless and stealthy attacks that bypass the traditional security systems like in nowadays every system has some kind of malware system that detects only after the attacks has been done in our system. So this is like a pre-executed one which can be used as a precaution for the attacks to cut it at the early stage itself. So now let's check on the statement of the problem. So existing antivirus system depend on the signature-based detection, so which cannot be detected new malwares like that and all. And the zero-day attacks remains undetected until the damage is done. So this was the main thing that we have been focused on this project. And the static analysis also fails to identify the malware that activates only during the execution. So that's the biggest drawback in traditional malware system. But in our system, it can able to detect when the attack is on the ongoing process itself. And advanced malware uses evasion techniques to bypass the security tools. And the organization lacks real-time behavior monitoring at the OS level. So this was a major problem for various kind of attacks to be happen to a reason. So now let's we check on the scope of the project. So when we take on the scope of a project, this project is focused on designing and implementing a runtime malware detection system that monitors the overall OS behavior to identify anything like malicious activities has been performing in our CPU or any other thing has been consuming our memory. So like that, it always watches onto it. It aims to detect the known and unknown and zero-day malware by analyzing the real-time system behavior rather than relying on traditional signature-based methods. So, who are the target audience for this project is like cybersecurity professionals and analysts, an organization seeking endpoint protections, then IT administrators and system engineers, academic researchers and students in cybersecurity. So these were the target audience. So what we have been delivering from this product is a functional runtime malware detection application, a real-time system behavior monitoring module, a malware detection and alert generation system, a log management and reporting dashboard, and a procurement documentation and test results. So this was the deliverables we have been performing in our project. Now, like inclusions, like what are the inclusions being used in this project? This like OS level behavior monitoring, like processes and files, and those network activities has been monitored in this process. Then rule based or ML based malware detections, a real-time alert notifications, a system activity logging and reporting, and then a user-friendly interface and dashboard where everyone can able to understand what is happening and when an attack is happening or ongoing, how it shows in the interface to the normal users or for any professionals like that. So exclusion is a signature-based malware scanning we cannot able to include in this project. A mobile or embedded system malware detections, a deep hardware level like firmware or BIOS analysis, a manual malware removal or recovery tools like that we have been excluded from this project. So data, a system-based data such as process execution logs, file system access records, registry system call activities, and network connection details, and synthetic or stimulated malware behavior data for testing. So the limitations in this project is high system activity may increase the resource usage. So this was the limitations, and the detection accuracy depends on the quality of behavioral data. So based on those behavioral data, it takes some time to uh, like detect and to make the accuracy will be sometimes high or sometimes low based on those performance. Then sophisticated malware may mimic legitimate behavior, and the limited support for non-supported operating systems are also a main drawback in this one. So methodology, how it works. So data collection. So our application will collect the real-time OS level activities like including the processes, files, and network events like that. Then it processes the data. So once it takes those data from the real-time analysis, it goes to the ML1. The ML1 are like provides various kind of things like filter and the non-collected data to reduce the noise. Then a feature extraction, where a meaningful behavior features from the system security logs will be extracted, and this will go to the malware detection and classifications. So this apply rule based logic or machine learning models to classify the behavior as normal and malicious. Then alert generation. So whenever there is a high spike on CPU or high spike on memory, it immediately triggers a real-time alarm so that we can detect that some attack has been performed in our system like that. And integration and testing. This integrates all modules and tests the system for accuracy, performance, and reliability. Then, so this is how the architecture diagram looks like for our project. So first, it will monitor the OS activity. Then it will take the data in the pipeline. Then future extractions will be happen to make it polish the data and send it to the detection part. And the detection engine will check onto those things like whether the CPU has been spiked high or the memory has went on to the spike mode. So everything has been analyzed. Once if the CPU has been strike more than what we gave in those detection part, immediately triggers an alarm. So it tells that there has been an attack has been performed in this one. So the alert module will be there and it should be showed in the dashboard itself. So this is how the architecture diagram will look like that. Then a use case diagram, so where our user uses it and he views it and like things like that has been used. And this is how the use case diagram, like how the user and admin will generate monitoring systems and reports to the user, and user will view the alerts and reports and monitor systems like that. Then a design class diagram, so what are the classes has been performed in this, and it's a sequence diagram like what has been performing in that. So this is how the sequence diagram, how the malware has been detected using this project. So this was the one, and this is the most important thing. Like, what are the algorithms have been used in our project? The first thing is isolation forest. This is the thing that detects the normalizes in the system behavior by isolating abnormal process and those network activities. Then one class support vector machine. So this is the most important one which learns the normal system behavior and identifies the deviations as malicious. So whenever the CPU spikes high or the memory spikes high, this one class support vector machine will identify whether this attack is like a normalized data or it's like an abnormal one, and it chooses and then it alerts to the user. And random forest classifier. So this classifies the system activities as benign or malicious using the multiple decision trees. Then support vector machine. This separates the normal and malicious behavior based on the extracted feature. Then K means clustering. This groups the similar behavior patterns. So whenever the input has been taken from real-time monitoring, it compares with this one. And if the compared one is equal to the one which has been loaded as a malicious, which has been framed as a malicious one, then it immediately triggers an alarm to the user itself. So this is the algorithms we have been used in the project. And the other one is logistic regressions have been used. A Navy based classifier has been used for the malware detection. The decision tree algorithm applies rule based decision to classify the malicious activities. Then threshold based rule engine like detects malware when system behaves exceeds predefined limits. Then time series analysis. So it's like predicting one. So we have been used time series analysis to predict like what kind of attacks will be happen when the CPU goes. For example, let's we take like that when the CPU goes above 90 means when the CPUs are at the stage of 86 to 87, this time series analysis will predict that it can go above 85. So it will immediately like detects it and then it makes the classification in a more predefined way, and it triggers the alarm for that one. Then hardware and software selections. So it's like basically futuristic ones. So systems like CPU and smoke carbon monoxide, main memory will be used, storage and network interface. Then let's we take about selection, like operating system, like anything like Windows or Linux. Then programming language is definitely a Python, and we have been used machine learning frameworks, and database is MySQL, and web framework is Flask or Django. So this is was the hardware and software selection. Then implementation. So how we implemented this project? The implementation begins with the development of an OS level monitoring module to capture those real-time system activities, including the process execution, file access, and network connections. So this collected data is pre-processed to remove the noise and normalize the values. And the future extraction is performed to generate the behavior patterns from the raw data. So these features are passed to the detection engine, which applies machine learning or rule-based algorithms to identify the malicious activity. So whenever the malicious behavior is detected, alerts are generated logged in the database. So the dashboard displays the real-time alerts, logs, and reports to a user or administrator. So it's like a precaution one. Whenever any attack has been happened, this will immediately triggers it. So these were the code segments. Uh, so now let's we move on to the demo part. How our system really works in real time like that. So now let's see, check on the implementation part. So this was the interface of the dashboard. So how it looks like and the infos has been given. Now we go to the detection part. So now when we click on to the start monitoring button, it will shows the CPU usage, memory usage, and the process and network. So let's we simulate a kind of attack. We will inject the malware. Yeah, when we check on to that, the malware has been injected. Like from the pipeline have been used. A fake one so that we have been used how they works with in a real life. So now analyze this page where how much the attack has been analyzed, like where the spike has been hitted, when the usage of the malware has been performed in that, and the network activities has been analyzed, and also we can see that how the spike has been went up and down. So malware detection timeline are also showed, and from this log records we have been see how a safe system will looks like, and when the malicious hits how it goes on like that. So this was the implementation part. After we using it, we can click the push monitoring button. So it will the so we have been saw the output in the previous demo session, like how it works. So the browser of a website will show first the user needs to enter login details. In case if the person has not registered, he needs to sign in or register for the website. After logging into the website, the following page will be shown to the user. If user wants to view the reviews of the product, he needs to click the view review action, and this will shows what kind of attacks has been performed in that. And also this person needs to like the following logs has been recorded in this. So this red point indicates uh, whenever the CPU strikes more than high, and the green point is like a normal one. So the test cases what has been performed, and from this project we have been delivered the results like accuracy about 90 percentage, and precision like 93 percentage, and recall 92 percentage, inference like effective predictions, and it with the faster diagnosis. So the conclusion of this project is the project successfully demonstrates an effective approach to runtime malware detection using OS level behavior analysis. By moving behind the traditional signature based detection, the system can identify the unknown and zero day threats in real life. So the implementation shows improved detection accuracy, faster response time, and reduced system vulnerability. This project mainly highlights the importance of behavior based security mechanisms and provides a strong foundation for developing advanced, scalable, and intelligent cybersecurity solutions. So, this like when we take the future work for a project, we need to work more on these parts to better the analyze sequences, system behavior, and we need to also improve the accuracy for our detection. So this in the future this would help to identify more complex and stealthy malware patterns. And additionally, like we need to extend in the AI techniques will improve the transparency by explaining why a particular behavior is classified as malicious. So the automated response mechanisms such as system isolations and threat remedies can further strengthen the real-time protection and reduce human intervention. So thank you. This was our project. So thank you.